Hello friends, in this video we'll be discussing objective from HC Verma and the chapter is force, the forces. Okay, so let's start with the first question. It's a very fundamental and basic chapter and very few objective questions are there. So let's wind it up. When Neil Bohr shook hands with Heisenberg, what kind of forces they exert? Because they when they shake hands, so their molecules of or atoms of their hands interact and their interaction is electromagnetic. Okay, so next is EGN represents electromagnetic, gravitational and nuclear forces. आपको बताना है which their order of magnitude for given separation. So we can say that in this electromagnetic force is the strongest and weak nuclear forces are the weakest, because the only nuclear force that will exert between two electrons will be weak nuclear forces, not the strong nuclear forces. Okay, so electric field, electrostatic repulsion, gravitational attraction, and then the weakest will be weak nuclear forces. Okay, the sum of all electromagnetic forces between different particles of the system of a charged particle is zero, irrespective of the signs, because there will be these forces will be produced in pair, force on 1 by 2, and there must be a force on 2 by 1. So when add these type of forces, we will get a zero resultant. In the next part, 60 kg man pushes a 40 kg man by 60 Newton, then obviously 40 kg man will also push the other 60 kg man by same force of 60 Newton, just in opposite direction because of action reaction pair. Force on A by B must be equal to force on B by A in magnitude and opposite in direction. Okay. The next question, a neutron exert a force on a proton which is, obviously neutron has some mass, proton has some mass, so they will attract each other gravitationally, but neutron is neutral, so there will be no electromagnetic force, but there will be nuclear forces between them and there will not be any weak nuclear force. So gravitational attraction and strong nuclear forces will be there. Okay, but when a proton exert a force on a proton, then gravitational, in addition to these two forces, gravitational and nuclear, there will be electromagnetic force also, because both the particles have charge, proton and proton. So answers will be A, B and C. The next question says, mark the correct statements. Nuclear forces between two proton is always greater than the electromagnetic forces between them. Not always. The statement is valid for smaller separation or the separation which is of the order of femtometer, then this statement is valid. But as the separation increases, electromagnetic forces dominates over nuclear forces. Okay, so statement A is not correct properly. B, electromagnetic forces between two protons is always greater than gravitational forces between them. Yes, because both are inverse square forces for the same distance, electromagnetic force will always win as compared to gravitational force. So B is correct. Gravitational force between two proton may be greater than nuclear force between them. Yes, for some separations, for large separation, gravitational force may be more. So as may is written, the statement C is correct. Electromagnetic force between two protons may be greater than the nuclear forces. Yes, statements are also correct, again for the larger distance or separation between them. Electromagnetic forces may dominate over nuclear forces. The next question is, if all matters were made of electrically neutral particles such as neutrons, then there would be no force of friction, there would be no tension, there not possible to sit on a chair, the earth could not move around the sun. Okay, these three, first, second and third, are electromagnetic forces. tension, friction, and normal reaction. So these are not possible. So because all the particles are neutral, so there will be no electromagnetic forces. But fourth one is gravitational force, so it will still exist. Hence, option D is the only option correct. Which of the following system can be adequately described by classical physics? Obviously, motion of a ball and motion of small particles like dust particles can also be described using classical physics. But hydrogen atom and a neutron changing a proton are explained by basically modern physics, which is which you guys will study when at the end of 12th syllabus. Okay, so A and B are correct. Next is two ends of a spring are displaced along the length of the spring. All displacement have equal magnitudes. In which case or cases the tension or compression in the spring will have maximum magnitude. Okay, so if displacement of both the ends are in opposite direction, for example, if right end is moved towards right and left end is moved towards left, then the maximum elongation will be there. If left hand is moved towards right and right hand is moved towards left, so there will be maximum compression. In the next other two cases in which both the ends are moved in one direction, there will be no compression or elongation. So option A and D are the correct answers. Right end displaced towards right, left end towards left, right towards left, and left towards right. Okay. In B and C, there will be no elongation or compression at all. Action reaction pair acts on two different objects. Obviously, they have equal magnitudes, they have opposite directions, they have zero resultants if taken in pair. Okay, if they are part of uh, a system which involves both. Okay, for example, if a person is standing or a block is placed on a table, and if we draw a diagram which involves table as well as block, then these normal, which are action reaction on block by a table and by table on block, will cancel each other. Okay, so option D is also correct, but it's a tricky one, so please listen it carefully, that they may cancel or they may have zero resultant, but only in that case when both the objects which are applying forces are part of the system. Okay, thank you.